Cooperative Extension Specialist with the University of California, and we're here at the Westside Research and Extension Center in western Fresno County. And we're doing work on industrial hemp, a number of different types of industrial hemp, potentially as a crop of interest in the San Joaquin Valley, in this area that traditionally has been a lot of different vegetable crops, cotton, small grains, sugar beets, and those type of crops in the past. So this particular study that we're in is one where we're looking at trying to evaluate responses to different levels of amounts of applied water, and also trying to establish then what the water use requirement is for industrial hemp. And one of the challenges in industrial hemp is that it's a very diverse group of cultivars. Some very short in terms of maturity, some much longer growing season requirement, and again, big differences then in the size of the plants. We have everything from autoflower types here, which are not photoperiod sensitive, that could be grown at various different times of the year, but mostly are quite short season, as little as maybe 70 to 80 days after planting from seed, versus the ones here in the back, which are photoperiod sensitive types. And these are ones that are more likely to be harvested probably at least 110, maybe 120 days after plant direct seeding. Much bigger plants present different challenges, not only in terms of things like water use and nutrient requirements, we would imagine, but also probably quite different in terms of maybe timing of harvest and the type of requirements for equipment for harvest. So again, these type of studies and some others that are related to optimal planting density type of considerations, use of transplants versus direct seeded are some of the types of things that we're looking at both here and in studies that are complement studies that are being done up in the Davis campus.
Yeah, hi, I'm Dan Putnam here at the University of California Plant Science Research Farm in Davis, California, and we're conducting research this year on hemp, industrial hemp that is currently being grown commercially in all states of the Union and here in California as well. We out here in the Plant Science Research Farm, we're testing irrigation needs of hemp across a range of varieties. Currently it's August 12th in 2020. You can see the growth of the crop has been excellent. We planted this crop about the 18th of June. Within about 2 months' time, it's really put on a lot of growth. And in this trial, we're testing two types of varieties. One is what we call a full season photoperiod sensitive type, which will start flowering pretty soon here. These plants are not quite yet flowering, but they're just beginning to show flowering. We call these the full season types. And they will continue to flower in the fall of the year, and the harvest will likely be in late September or October, depending upon the variety. The water needs of this crop might be very different than some of the other crops that we call the autoflower types. So this is a very different type of hemp, a genetic type which is what we call photoperiod insensitive. That is, these plants will begin flowering regardless of when they're planted at about 60 to 80 days. And actually, these crops are much shorter, much more compact than the full season photoperiod sensitive types. And so these will be harvested probably in the next 2 to 3 weeks. So industrial hemp can be grown for a number of different purposes. It can be grown for the seed, it can be grown for the fiber, and it can be grown for the inflorescence or the CBD or THC content of the flower. And in this case, we're very interested in the flower inflorescence of hemp plant. Hemp is a dioecious plant, which means that we have both male and female plants. We're taking what we call feminized seed, that is seed that is only producing female plants. And the reason for this is that we're primarily interested in the flower of the hemp, which produces the high CBD content, which can be then extracted for medicinal purposes.
In 2020, we tested 4 different lines, 2 autoflower and 2 full season varieties under 3 different irrigation regimes, either fully irrigated or 40 or 70% of full irrigation needs. at both Westside Research and Extension Center and UC Davis.
Hi, I'm Maya. I'm a junior specialist on this hemp project here. My job is myself and our awesome field crew take care of this field, make sure all of our experiments are running successfully, and I collect data along with my student assistants. And then it's up to me and Dan to work together and come up with our results. There might be a lot of hard things about 2020, but one of the easy things is that it's 2020 and technology allows me to control my irrigation through my phone. Here we have our irrigation station and our 100%, 70%, and 40% treatments, which are distributed throughout the field. And here we have our fertigation equipment, which allows us to inject nutrients throughout the field. Here we have a neutron probe access tube. It allows us to take soil water data down to a depth of 8 feet, letting us measure the distribution and the actual amount of water in our soil.
Okay, we're in planting density study that's being done with a couple of different cultivars that are the autoflower type, the non-photoperiod sensitive types that are of interest. So these are some plantings that were done on, I believe we have 6-inch, 12-inch, and 18-inch spacing on the rows, 2 rows per 60-inch bed in this particular field, and this looks like this is probably the high density treatment in this particular one. And part of the problem with these plants, which tend to be a little more compact and all, is that you want to make good use of the space when you're growing these. And so again, with plants that can be either expensive as transplants or limited quantities of expensive seed, you'd like to know what type of a density will actually give you a decent yield. And so this particular study is then looking at those 3 different densities. This is our second year at both Davis and at the Westside Research Center looking at planting densities with these autoflower types. One of the benefits of being able to have these field trials to do evaluations of at least a new to us crop like industrial hemp is that one of the things that's going to happen in an open field situation with a lot of other crops around, we're in an area where we have cotton and sorghum and corn and garlic and onions and tomatoes and a big mix of crops, a lot of tree crops and vines as well. Plus all the weeds that go along with those crops. So these are exposed to a mix of potential disease situations and insect pests as well. One of the things that we can do then in all of these trials, whether it's an irrigation or a density trial, is try to make observations on what shows up in terms of diseases. So far in these trials this year at Westside, we have noticed repeatedly what we've been told by some pathologists is likely beet curlytop virus, which shows up as some abnormal plants in terms of stunting and kind of a pinwheel appearance on the upper parts of the leaves. But then in terms of insect pests, last year we noticed that we did have corn earworm and tobacco budworm that were quite prevalent that we actually had to treat for in order to avoid some of the damage to the reproductive structures, the colas, flowers at the upper part of the plant. And in this particular field, one of the things that we did yesterday and the day before was to go through in the morning hours when it's easier to inspect for worm damage. And in this particular set of small plots here, all of the areas where you can see the orange flags are ones where yesterday we identified worms of different types. Ones that were identified yesterday included the Lepidoptera of types, the worm stage basically of tobacco budworm, corn earworm. We have seen cabbage loopers in here as well, and we also did find some species of armyworm that we haven't really identified yet. So on an ongoing basis through the rest of the season, we're going to be doing these same type of observations. Hopefully we'll be able to work with both UC entomologists and pathologists, and where we'd be able to send in samples and get confirmation rather than just cursory observations, but actual confirmation of what it is that we're looking at here in these fields.